This program is presented by University of California Television. Like what you learn? Help others discover UCTV podcasts by leaving a comment or rating for us in iTunes. Also, make sure to check out and subscribe to our YouTube original channel, UCTV Prime, available only on YouTube. This UCTV podcast is sponsored in part by Audible.com, your destination for the widest selection of digital audiobooks available, including many by guests you've seen on UCTV. Audible.com is offering UCTV viewers a free 30-day trial subscription and one free audiobook download. Just visit audibletrial.com/UCTV to sign up. And thanks.
Okay, we have our final speaker for this block of session. We have Eric Prather speaking next. And Eric has just recently joined the faculty at UCSF as an assistant professor in the Department of Psychiatry. He was a postdoc in our program previously, but his research focuses on the complex interactions between psychological processes and sleep as they relate to physical and mental illness. And he has specialized training in psychoneuroimmunology, and his research on the immune system is really key as key physiologic mechanism between psychology and health. And he does a lot of work looking at the immune system, but also metabolism and obesity, and he works with several of us. So I'm really excited to present him and his talk on Double Trouble, the complex associations of sleep, stress, and biology.
Thank you, and it's an honor to be up here with all of these other amazing sleep researchers, and also to help organize this symposium. I'm so happy that everyone turned out and it's been so attentive. All right, so I'm going to be talking about these associations between stress, sleep, and obesity-related biology, and the outline for this talk is pretty simple. So first, the first question is whether there is even a link between stress and obesity, and because you see that there are other points there, we will push on. And so if there is a link, if so, how does this happen? What are the behavioral and biological processes through which stress and obesity may be linked? Where does sleep come into this picture? Something that everyone in this room is interested in. And then I wanted to share a little data from our laboratory and an illustration of these complexities, focusing not on the link to obesity, but the interrelationship between sleep, stress, and adiposity in predicting biological processes relevant to obesity-related disease. And I do a lot of work on the immune system, and I'll be focusing on inflammation. But we'll get to that in a second. And then the implications of this work and work moving forward. So first, is there a link between stress and obesity? In our lives, we kind of intuitively know this to be true. We know what it feels like to undergo a chronic stressor or an acute stressor, what it does to our physiology as far as sympathetic arousal and changes in our endocrine function, changes in our behaviors. And we do our best to cope with this, and one of those mechanisms is potentially by eating. And in particular, there's good evidence showing that we eat more high-fat, high-sugar foods. And this is kind of part of our fabric of our culture, this understanding that there's this relationship between stress and these foods. And it's certainly not too far beyond that to think that that might be leading to obesity. So is there in fact a link? I mean, we believe that this is true, but what does the empirical evidence suggest? And in putting this talk together in the beginning to think harder about how stress is related to obesity, I was somewhat shocked at kind of how small the literature is on this, particularly with respect to prospective studies, meaning that you measure stress at one time point and whether that predicts obesity or BMI or whatever weight variable that you want later in time. However, there was a recent meta-analysis, a compendium of of the available studies and giving us an effect size of how strong this relationship is, done by Andrew Steptoe's group at University of College London. And what they did is they found 32 studies, 13 of which had a follow-up of over 3 years and looked specifically at job stress and general life stress, with the outcomes being kind of the ones that you would expect in epidemiologic samples, so BMI, waist-to-hip ratio, weight, and waist circumference. I think one important fact about this was these outcomes weren't self-report. They were actually done in the clinic, and so we know that they're relatively valid outcome measures. But the result was somewhat surprising. So there was increasing effects, so meaning that stress predicted an increase in weight in 8 studies, a null effect in 22 of these studies, and a decreasing effect in two of the other studies. But when taken in total, there did seem to be an overall modest relationship between stress and later weight, with the authors saying that psychosocial stress is positively related to the development of adiposity in prospective studies, although the effects were modest and smaller than assumed in the lay literature. So there does seem to be an empirical relationship, but it's not an overwhelming one. I did want to bring up one study that wasn't included in this meta-analysis, in part because this was a study facilitated by the UC Berkeley Center for Weight and Health, done by the group there using the National Growth and Health Study, a sample of over 2,000 girls followed longitudinally and had BMI and psychological stress assessed throughout that period. And so you can see here, as Dr. Dahl will certainly talk about in his next talk, kind of these changes that happen in adolescence and potential explanations for those, as well as, they found there's an increase overall in weight, but also that chronic high stress cumulative over the time predicted this increase over time, so that greater cumulative chronic stress in both black and white girls predicted increasing BMI over that 10-year period. And there was also a stronger effect in the African American girls, suggesting potential racial disparities as related to obesity, certainly relevant to Dr. Grander's talk towards the end of the day. So there does seem to be a relationship. What are the potential mechanisms? For a stress researcher, kind of some of the tools in our tool belts is stress hormones when we think of biological factors. And kind of the one that most often comes to mind is the role of cortisol. Cortisol released from the adrenal glands in response to a stressor has been shown to be linked to increase in adipose deposition, insulin secretion, and Mary Dahlman's work so eloquently at UCSF has shown that it increases motivation for high-fat, high-sugar foods. In addition to that, there has been some evidence that acute stress increases cortisol, and among individuals who show the greatest reactivity to this stress, that's been determined as high reactors, when given the opportunity to eat after a stressor, have been shown to actually consume more calories. So you can see here that these are the high reactors in response to a stress session. In this case, it was performing a speech, kind of a standardized go-to method for stress researchers. Not so much unlike this, although it's in front of a panel and it's evaluative in nature, and it causes a robust stress response, and I'll talk more about that in the data that I illustrate. But these high reactors were also the ones that consumed the most calories when given the opportunity. And this was compared to a control condition when they didn't undergo a stress, and these high reactors didn't differ from low reactors in the calories that they consumed. So there does seem to suggest that stress and the cortisol that's produced is also associated with behavioral change in caloric consumption. In addition to cortisol, the other mechanism that I'm going to note in this selective review is the role of neuropeptide Y. Kuo and colleagues in some elegant studies published in 2007 in Nature Medicine showed that stress upregulates NPY in a glucocorticoid or cortisol-dependent manner, leading to adipose growth when mice were fed high sugar, high fat diets. So you can see these are the ones that are fatter, very unhealthy mice. And Warren and Dahlman in the commentary from that study kind of put it all together here. So stress leads to glucocorticoids that can potentiate the sympathetic neuron in adipose tissue, leading to the release of NPY and proliferation of adipocytes and epidipogenesis, and macrophage infiltration, which is something I'm just highlighting here because it's going to be relevant to what I talk about towards the end, which in turn can lead to insulin resistance. So there is kind of a complicated but verified pathway with respect to stress and a potential biological mechanism to obesity, or at least adipose growth. But how is sleep involved? Again, this is kind of an intuitive thing. I mean, we know that individuals who are very high stress during work, have a difficult time sleeping. You know, they don't fall asleep as quickly. They often can have fragmented sleep, less sleep continuity, and report that their quality of their sleep was poor. In the same way, there's some evidence that people who don't get enough sleep certainly have changes in their mood, but there's now emerging laboratory evidence suggesting that individuals are even more sensitive to stress exposure. Some of this work comes from Matt Walker's lab at UC Berkeley, where Stephanie Greer is from, showing that individuals that are deprived from a night of sleep, their amygdala, the emotional part of the brain that helps gate stress physiology, is more reactive to emotional phases the following day compared to their resting control condition. And then at the University of Pittsburgh, Peter Franzen and colleagues, a study that Dr. Dahl was also involved in, showed that individuals who are deprived of sleep when forced with a speech task the following day show more reactive blood pressure. So a physiologic marker of potential cardiovascular risk compared to a non-sleep day. So there's kind of this emerging evidence that poor sleep, in fact, makes individuals more sensitive to stress exposure. And so it's a vicious cycle. You know, sleep begets stress, stress begets sleep, and I'm sure many of you are familiar with this cycle. And what's so interesting to us, to our laboratory, and to me particularly, is the influence of sleep on biology. And we've heard this very eloquently from Dr. Van Cotter and other folks, showing that disrupted sleep is associated with insulin resistance and impaired glucose tolerance, particularly under laboratory conditions. Increase in low-grade inflammation, which I'll talk about in a moment, dysregulation in cortisol and satiation hormones like leptin and ghrelin, and then alterations in food preferences, as Stephanie mentioned. And what's so intriguing to me is that these very same biological pathways that are associated with disrupted sleep are very similar to those seen in response to psychological stress. There's these shared biological mechanisms. And in the same way, the poor sleep and elevated levels of psychosocial distress or stress are associated with increased risk for a variety of obesity-relevant medical conditions such as cardiovascular disease and hypertension, type 2 diabetes, and the metabolic syndrome. So there seems to be this inner working at a biological level through which sleep and stress are involved. And so here is just kind of a very simple working model where you get kind of stress and eating behavior related and obesity. And it's like sleep is involved in all of those factors. And so you can see how poor sleep might modulate this system, in part through its effects on these various aspects, in turn leading to changes in biology and obesity-related disease. I think something I didn't note here, but the biology also goes up this way, too, to affect obesity. And there's kind of new information about how some of these biological factors can act on the brain to influence the way that we perceive stress and the way that we sleep. And in the data piece that I'm going to present now, I'm going to be focusing on this part here. So we're not going to talk about eating behavior, we're not going to talk about obesity-related disease, with the focus on inflammation, because I actually think that this is one of the central mechanisms through which these factors impact obesity-related disease. So a little bit of inflammation for those who are unfamiliar. So inflammation is an extremely adaptive process necessary for survival. It's mediated by proteins known as pro-inflammatory cytokines or other proteins that are produced by immune cells and fat cells. As I mentioned, necessary for survival. They orchestrate the immune system. They orchestrate the communication between cells and throughout the immune system, and particularly integral in wound healing. But at chronic levels, inflammation has been predictive epidemiologically in laboratory-based studies towards disease outcomes, particularly cardiovascular disease, for instance. But getting back to how it's related to obesity, as I mentioned, you get this macrophage migration, and this is one of the key sources of inflammatory cytokines. And so as the adipose grows, more cells migrate into this area, leading to crosstalk between macrophages and the adipocytes. Adipocytes begin to release pro-inflammatory cytokines as well as macrophages there. So when you get obese tissue, you begin to get more and more inflammation. Again, the link between obesity and obesity-related disease. And so for the data illustration here, I asked the question, because we know that there's emerging evidence that poor sleep is associated with increased reactivity to stress exposure. I wanted to look first at whether poor sleep affects stress-induced inflammation. So in response to an acute stressor, whether poor sleep modulates those levels in circulating blood. And we're looking at pro-inflammatory cytokines, specifically IL-6, one of the essential ones that we measure in humans, typically, as well as the ratio of IL-6 to IL-10. And then whether adiposity matters. I just talked about how this migration seems to be important, and so we can look at whether this varies as a function of adiposity. I mentioned, to many might be unfamiliar with this balance, the IL-6 to IL-10 balance. IL-10 is an anti-inflammatory cytokine and has immunoregulatory properties such that it's released from when IL-6 is released, IL-10 is kind of released in response with the function of resolving that inflammation, kind of as a checks and balances system. And so the ratio of IL-6 to IL-10 is thought to estimate a pro-inflammatory bias. So the higher the ratio, potentially the worse off you are as far as your inflammation system. But it has previously been shown to be responsive to acute laboratory stress, and so that's why it was included here. The study was 48 postmenopausal women. This was recruited from a prospective study of caregiving on immunologic aging. So as a consequence, 21 individuals were caregivers and 27 were non-caregivers. In all the analyses, I statistically controlled for the status of whether they were a caregiver or not. It was a midlife sample, as Sean indicated. It's 51 to 79 years old. All these individuals were free from chronic medical conditions and medications known to affect stress hormones, and they were all non-smokers. So it was a good, healthy sample of 48 postmenopausal women. And to look at sleep, it would be nice to get more objective measures of sleep. And in some time in my lifetime, I would love to do a sleep study. In the laboratory, but the evidence showing this link between sleep deprivation and stress reactivity, sleep deprivation is certainly an extreme form of sleep loss. Something that, though it in partial sleep paradigms can help model what chronic sleep debt exists, have always been more interested in kind of the natural variation in sleep. And so we used the very validated Pittsburgh Sleep Quality Index to get a global sleep score. And we did body measures in the clinic to look at the role of adiposity. So body mass index, sagittal diameter, specifically sagittal diameter because it gives us a good estimate of visceral adiposity, so kind of the bad fat around the organs. IL-6 and IL-10 were measured by high sensitivity immunoassay at Stanford University by Firdaus Dabar. And then the procedure. So this is a stress reactivity study, and like I mentioned, it's about performing a laboratory speech task. And so individuals underwent a 1-hour resting baseline where they came in and they sat down and kind of relaxed. They did get a catheter in their arm to draw blood, but then we left them for an hour period so that their body could reset itself. And then individuals did a 20-minute standardized laboratory stress task, and this was included a speech and a serial subtraction task. This is kind of the classic speech or stress paradigm. And then there was a 70-minute recovery period, and blood sampling took place at baseline, 30 minutes, 50, and 90 minutes after the beginning of the stressor, so that we could kind of look at the trajectory of change over time. Just a brief analytic issue. So because it's repeated measures, we were able to utilize a multi-level growth curve modeling technique where we could estimate the linear effect. It's not particularly important, but and then we looked at the interactions of time, body mass index, and sleep. And then when interactions were significant, we did simple slope analyses to probe to figure out what it was that was different. Again, the descriptive statistics, the average age is 60. In the overweight group in general, they had some depressive symptoms. That all of this stuff was adjusted for in the analyses that I'm going to show you, and here was their sleep score. So the results. So as you would expect, in any time you would do a stress study like this, you would expect a linear increase in these pro-inflammatory cytokines. This is what you get traditionally, and that's exactly what we found. So this isn't looking at any other factors. This is just on average, individuals showed an increase in IL-6 in response to this acute stressor. And the very same thing is seen for the IL-6 to IL-10. This is a significant time effect. And then we found that poor sleep, but not BMI, these were looked at separately, potentiated IL-6 and the IL-6 to IL-10 response to acute stress. So here you see this. So you get this kind of graded effect that good sleepers had the least slope. Average sleepers had a steeper increase, but the poor sleepers had a very strong high increase. Suggesting that poor sleep is in some way operating to moderate the effect of this stressor on biology. Specifically, in this case, it's IL-6 to IL-10, but it was the same for IL-6. But interestingly, it was the combination between BMI and sleep that was the worst. So here we see poor sleepers with a low BMI had the weakest slope. Here's good sleepers, and this isn't broken down by BMI because the interaction between good sleepers and BMI was non-significant. But poor sleepers with high BMI had the strongest slope. What about the role of visceral fat? And this was, it looks very similar, but the statistics suggest that this was much stronger than the BMI. And this finding is actually independent of BMI in this data. So there's something specific about visceral adiposity in this modeling. And I will say that visceral fat, when we looked at that by itself, it also predicted increase in IL-6. So visceral fat seems to be a kind of an active ingredient, but when put in combination with sleep, seems to put you in a whole other bracket of potential risk. Potential risk, be clear. These are nothing, no, they did not gain any kind of disease from this, but maybe in the future. So what are the implications? There seems to be a clear connection between stress and sleep, stress reactivity in sleep that was accentuated by visceral adiposity. And to me, really highlights the need to consider the complexities. Had we looked at just BMI and sleep individually, we would have gotten this sleep effect, but there would have been nothing for BMI. And it seems that the combination of the two put people in a subset that may be of particular deleterious effects downstream. And so looking at the interactions between psychological, behavioral, and biological factors. And I think it raises questions about whether there may be multiple entry points for affecting obesity and obesity-related disease. And so you can imagine beginning to intervene on sleep or intervene on stress, through weight loss, and see how that plays out in this clearly complex and interrelated cycle. And to that point, there have been very few studies that have begun to look at this, but this was one that I wanted to highlight. So this is from Elder and colleagues at Kaiser Permanente up in Oregon. And they looked at 352 people that were part of a non-randomized behavioral intervention of weight loss that included group sessions and the DASH diet and exercise, and looked at whether perceived stress and habitual sleep duration were predictors of weight loss in this particular sample. And what they found was pretty intriguing, and this is kind of a complicated graph, but basically poor sleep, shorter sleep, and in this case on the y-axis is probability of success, and they define success as 10 pounds of weight loss, varied as a function of sleep duration, but particularly when you looked at how high their stress level was, so at the same time, so the combination. So you can see here that this is the stress level, and the higher is worse, and this is the probability, and this is the lowest sleep, and the highest stress seem to make the biggest difference, suggesting that both of them are important, and potentially when they're both online, that might have the most important part with respect to weight loss. So it may lead you to, what about stress reduction? And I can't answer this. I think it's a very important and intriguing question. It's something I just wanted to highlight just briefly because at UCSF, as part of the OSHA study, there's an ongoing stress reduction or stress management program, a randomized trial of 6-month weight loss where they looked at nutrition, exercise, and a stress management protocol where sleep was included as part of the assessment as well as behavioral and biological pathways. So when this data is ready, we might have a better opportunity to disentangle some of these clearly important factors. So with that, I want to thank the key collaborators on that work that I presented and take any questions. Thanks.
On your work on acute stress, diet levels or something like that? Or?
Yeah, I mean, I know that Alyssa particularly has done work on kind of dietary restraint and dietary attitudes and how it might affect some of these stress physiology. And yeah, I think you're right. I mean, I think in part it's about kind of the appraisal of whatever it is, and if you appraise it as stressful, then some of these things come online. I don't think there's necessarily specificity about food, but it's certainly more relevant when you're talking about obesity-related factors. Yeah.